If x is equal to cos alpha plus I sin alpha, iy is equal to cos beta plus I sin beta, x raised to m y raised to n plus 1 by x raised to m y raised to n is equal to 2 cos into m alpha plus n beta. If a is equal to cos 2 alpha plus I sin 2 alpha, b is equal to 2 cos beta plus I sin beta, and c is equal to cos 2 gamma, root of ABC plus 1 by root of ABC is equal to 2 cos into alpha plus beta plus gamma. Find all the values of the following: I raised to 1 by 3, square root of minus 3 minus I the whole power of 2 by 3. If x is equal to a b, y is equal to a omega plus b omega square, z is equal to a omega square plus b omega, show that xyz is equal to a cube plus b cube. Prove that I by omega cube is equal to 1. Then a plus b plus c into a plus b omega plus c omega square into a plus b omega square plus c omega is equal to a cube plus b cube plus c cube minus 3abc. One by 1 plus 2 omega minus 1 by 1 plus omega plus 1 by 2 plus omega is equal to 0. Find all the values of 1 by 2 minus I root of 3 by 2 and hence prove that the product of the values is 1.
Analytical geometry grew out of the need for establishing uniform techniques for solving geometrical problems, the aim being to apply them to the study of curves, which are of particular importance in practical problems. A conic is the locus of a point which moves in a plane, so that its distance from a fixed point bears a constant ratio to its distance from a fixed straight line. Fixed point called focus, the fixed straight line is called directrix, and the constant ratio is called eccentricity, which is denoted by E. Parabola. The locus of a point whose distance from a fixed point is equal to its distance from a fixed line is called a parabola. Standard equation of a parabola. Now, let us derive and trace the standard equation of a parabola. Given a fixed point f, fixed line L, eccentricity E is equal to 1, moving point P of x, y. Steps to derive the standard equation of the parabola is shown on the screen. First, we simplify the equation of the parabola y squared minus 8x plus 6y plus 9 is equal to 0 to get y squared is equal to 8x. Here, x is equal to x and a is equal to 2. The type is open rightward. The axis, vertex, focus, directrix, later secum, and length are given in the table. For this example, we simplify the equation of parabola x squared minus 2x plus 8y plus 17 is equal to 0 to get x squared is equal to minus 8y. Here, x is equal to x minus 1 and a is equal to 2. The type is open downward. The axis, vertex, focus, directrix, latus rectum, and length are given in the table. Ellipse. The locus of a point in a plane whose distance from a fixed point bears a constant ratio less than 1 to its distance from a fixed line is called ellipse. Now, we will derive the standard equation of an ellipse given. Fixed point F, fixed line L, eccentricity E less than 1, moving point P of x, y. The steps are shown on the screen. For this example, by shifting the origin, simplify x plus 1 the whole squared by 3 plus y plus 2 the whole squared by 4 is equal to 1. X squared by 3 plus y squared by 4 is equal to 1. Here, major axis is along y-axis. E is equal to 1 by 2. Equations of the directrix are y is equal to plus or minus a by e. That is, y is equal to plus or minus 4. Therefore, the equation of the lattice rectum are y is equal to minus 1 and y is equal to minus 3. Length of the lattice rectum is 2b squared by a is equal to 2 into 3 by 2 is equal to 3. For this example, simplifying the equation of a point, the standard distance from a fixed point, we get a constant ratio 1 plus 2 greater than 1 by 9 distance minus from a fixed line is minus 2 the whole squared by 4 is equal to 1. Clearly, the transverse axis is along y-axis and the conjugate axis is along x-axis. Thus, transverse axis y-axis x is equal to 0, whose distance from a fixed point x minus 2 is equal to 0. Greater than 1 is its axis from a fixed y line is equal to 0 called a hyperbola. Y plus 2 is equal to 0. Here, a squared is equal to 9, b squared is equal to 4. Therefore, a is equal to 3, b is equal to 2. Therefore, the length of transverse axis is equal to 2a is equal to 6. For this example, simplifying the equation in the standard form of ellipse, we get y plus 2 the whole squared by 9 minus x minus 2 the whole squared by 4 is equal to 1. Clearly, the transverse axis is along y-axis and the conjugate axis is along x-axis. That is, transverse axis is y-axis, x is equal to 0, that is, x minus 2 is equal to 0. The conjugate is x-axis or y is equal to 0, that is, y plus 2 is equal to 0. Here, a squared is equal to 9, b squared is equal to 4. Therefore, a is equal to 3, b is equal to 2. Therefore, the length of transverse axis is equal to 2a is equal to 6. Length of conjugate axis is equal to 2b is equal to 4. From the given data, the transverse axis is along x-axis. By shifting origin to get x squared by 16 minus y squared by 9 is equal to 1. Here, the transverse axis is parallel to x-axis. Refer to x, y. Simplifying to get center 1, minus 2, foci f1 of 6, minus 2. Simplifying to get center C of 1, minus 2, foci f2 of minus 4, minus 2, vertex A of 5, minus 2, A dash of minus 3, minus 2. From given data, transverse axis is along y-axis. By shifting origin to get y squared by 9 minus x squared by 16 is equal to 1. Here, the transverse axis is parallel to y-axis. Refer to x, y. Simplifying, get E is equal to 5 by 3. Center 0, 0, C of minus 2, 1, foci f1 of minus 2, 6, vertex A of minus 2, 4, A dash of minus 2, minus 2. Parametric form conics. From the above table, we have two forms of representations of conics, that is, Cartesian form and parametric form. Now, we will derive the equations of chord, tangent, and normal to the conics. Chords, tangents, and normals. We derive these equations using both forms of conics. Cartesian form. Parabola. The equation of the chord using slope m and point x1, y1 is obtained as shown above. Thus, the equation of the tangent at x1, y1 to the parabola y squared is equal to 4ax is y1 is equal to 2a of x plus x1. To find the equation of the normal using perpendicularity, equation of tangent is 2ax minus y1y plus 2x1 is equal to 0. Therefore, the normal is the form y1x plus 2ay is equal to k, but it passes through x1, y1. Therefore, k is equal to x1, y1 plus 2ay1. Thus, the equation of the normal at x1, y1 to the parabola is y1x plus 2ay is equal to x1, y1 plus 2a. Ellipse. To get the equation of the tangent at x1, y1, put x2 is equal to x1 and y2 is equal to y1 in the equation of the chord. Therefore, the equation of the tangent at x1, y1 is obtained as shown above. To get the equation of the normal, use the perpendicularity property to a straight line. Therefore, the equation of the tangent is x1 b squared x plus y1 a squared y minus a squared b squared is equal to 0. Therefore, the equation of the normal is of the form y1 a squared x minus x1 b squared y is equal to k. But it passes through x1, y1. Therefore, k is equal to a squared minus b squared the whole x1, y1. Therefore, the required equation is y1 a squared x minus x1 b squared y is equal to a squared minus b squared the whole x1 y1, or a squared x by x1 minus b squared y by y1 is equal to a squared minus b squared. Hyperbola. Following the same procedure as in the case of ellipse, we get the equation of the chord as shown above. The equation of the tangent at x1, y1 is x1 bar a squared minus y1 bar b squared is equal to 1. And the normal at x1, y1 is a squared x bar x1 plus b squared y bar y1 is equal to a squared plus b squared. Asymptotes. An asymptote to a curve is the tangent to the curve such that the point of contact is at infinity. In particular, the asymptote touches the curve at plus infinity and minus infinity. Find the equations of the asymptotes to the hyperbola x squared bar a squared minus y squared bar b squared is equal to 1. Assume The equation of an asymptote is of the form y is equal to mx plus c. To find the points of intersection of the hyperbola and the asymptote, solve the above equation. The points of contact are at infinity. That is, the roots of the equations are infinite. Since the roots are infinite, the coefficients of x hat and x must be 0. Therefore, there are two asymptotes to the hyperbola whose equations are y is equal to b bar ax and y is equal to minus b bar ax. The combined equation of asymptotes is shown above. Rectangular hyperbola. A hyperbola is said to be a rectangular hyperbola if its asymptotes are at right angles. The results are shown on the screen.
Find the equation of the parabola if focus 2 minus 3, directrix y minus 3 is equal to 0. Vertex 0, 0, focus is equal to 0, minus 4. Vertex 1, 2, lattice rectum y is equal to 15. Vertex 3, minus 2, open downward and length of lattice rectum is 8. Vertex is equal to 3, minus 1, open rightward. The distance between the lattice rectum and the directrix is 4. Find the axis, vertex, focus, equation of directrix, lattice rectum, length of the lattice rectum for the following parabola and hence sketch their graph. Y square is equal to minus 8x. X minus 4 the whole square is equal to 4 into y plus 2. If a parabolic reflector is 20 cm in diameter and 5 cm deep, find the distance of the focus from the center of the reflector. The focus of a parabolic mirror is at a distance of 8 cm from the center, that is the vertex. If the mirror is 25 cm deep, find the diameter of the mirror. Find the equation of the ellipse if one of the focus is 0, minus 1, the corresponding directrix is 3x plus 16 is equal to 0 and E is equal to 3 by 5. The focus are plus or minus 3, 0 and the vertices are plus minus 5, 0. The center is 3, minus 4 and one of the focus is 3 plus root 3, minus 4 and E is equal to root 3 by 2. The length of the semi-major axis and the lattice rectum are 7 and 8 by 7 respectively. The center is 2, 5 and the major axis is parallel to y-axis. The focus are plus or minus 3, 0 and the length of the lattice rectum is 32 by 5. Find the focus of a point which moves so that the sum of its distance from 3, 0 and minus 3, 0 is 9.